So hi everyone, thanks so much for joining this month's KubeFleet community APAC community meeting series. The topic about this one is a little bit special. Traditionally, we've been using this community meeting series to introduce KubeFleet, the features, the new the features, the performance evaluation, etc. But for this week's meeting, will be the topic is about a new enhancement proposal we just added. To the project. It is our hope that through the discussion of this proposal, we can add some exciting new features, new experiences to the KubeFleet project. Yeah, so let's get started. Once again, I know I've been repeating this in every meeting, and I'm once again preaching to the choir here. But just as a brief introduction to our project, so we are a CNCF sandbox project that enables developers, operators, and admins to easily and effectively manage your Kubernetes clusters and your multi-cluster workloads. Our source code is on GitHub. We have a documentation site. Like I just mentioned, we are a CNCF project. We joined last year. So yeah, it's a really exciting initiative in the multi-cluster domain. So about the enhancement proposal process. So for now, in the past few cycles, we've been developing KubeFleet features within the team. But as an effort to make the evolution of KubeFleet more transparent to the community, we are adopting the enhancement proposal development pattern that has been commonly adopted in the Kubernetes community. It's pretty much similar to Kubernetes' own KEP Kubernetes enhancement proposal process. So we pledge to propose, debate, and track major changes, new features, and architectural overhauls using standardized documents available in a public repository, so that everyone in the community is welcome to make contributions, to give your opinions, and to help shape the direction, shape the future of KubeFleet in the coming cycles. So you can find the list of our current enhancements in the repo on the screen. So far we only have one, but there will be more to come in the future. So about our first proposal, the proposal is called Placement Policy APIs. This enhancement proposal is a new placement experience for KubeFleet that features a more simplified annotation workflow for setting up a placement. It features the ability to specify scheduling requirements and constraints for target clusters on an individual basis. It also features the option to request new clusters on demand based on a specific scheduling requirement and constraints. There are also various improvements to the scheduling and the rollout process and the status reporting. The goal is to make KubeFleet a little bit more easier to use, easier to understand, and to unblock future scenarios like resource migration between clusters. This proposal adds a set of new APIs under a different API group to the KubeFleet project. The reason why we do this is that we want to make sure that however fast we iterate on the new experience, the existing placement experience will remain intact, remain intact and supported and unaffected. We wanted this thing to be a new exploration where we can evolve fast, while still keeping what our current set of functionalities still available to all the users. So the reason why we have this new proposal is that we've been thinking about the future of multi-cluster management. Recently, we've been thinking about the challenges the project faces and how we can rise to those challenges. So far, in the past 1 year and a half, KubeFleet has been operating under a very specific assumption. We assume that KubeFleet runs in a multi-cluster environment with a relatively speaking fixed set of clusters. And when people want to play something, they tell us to do it in a kind of imperative way. The customers tell us to pick some clusters, and KubeFleet helps orchestrate the resources among them. But this whole idea, the whole concept, the whole assumption has a catch. You see, the interesting part about Kubernetes is that a Kubernetes cluster by itself is an abstraction layer over the actual computing resources. A Kubernetes cluster is like a stage where some actions happens, but the stage itself, however grand and marvelous the stage itself is not the action. What I'm trying to say is that unlike the action itself, the stage, the concept of the Kubernetes cluster, they can be easily rebuilt. They can be turned off. They can be turned on. They can be stopped somewhere and then restarted somewhere else. It can this the culture itself really doesn't matter. What really matters is the nodes behind them. And all the cloud providers, all the platforms, they are aware of this fact. So in recent years, we've been seeing a lot of Kubernetes automatic Kubernetes solutions across almost all cloud providers. GKE has one, Azure has one. We are all trying to simplify the whole flow to make sure that the concept of the cluster uh, is becoming more ephemeral than before, and that brings some changes to how we approach the multi-cluster scenario. The future we are facing right now would be that KubeFleet might be operating in a multi-cluster environment where clusters can be provisioned on demand, where we no longer have a fixed set of clusters. Instead we have a dynamic set of clusters where computing resources, the group of computing resources can be created, can be turned off during the whole during all the time. This new change requires us to do things in a more descriptive manner, in the sense that instead of picking specific clusters, customers will just be telling us the kind of clusters they like, and KubeFleet with some help from the platforming side or from the cloud provider side, if people can work together and make this orchestration possible. So this brings a major difference, a major deviation from our current experience. The tricky part is that our current placement experience, our current placement APIs is not yet ready for this vision. This is best exemplified by an example. Say here on the screen, we show one a resource placement API object, the API we support right now. And in this object, you can see that we use the pick n placement type. We pick two clusters, and we specify some cluster affinity terms, basically saying that I want to select clusters from the East US region and the Central US region. And let's suppose that currently in the fleet, there are four clusters, two in the East US region and two in the Central US region. What happens during the scheduling process is that KubeFleet will use all the affinity terms you see on the screen here, and use all those terms to validate each cluster there is in the fleet, and eventually all of the clusters will meet the requirement, and they all become candidates. And after we have four candidates, KubeFleet will pick two out of them, and to achieve a kind of like a deterministic processing, KubeFleet will when there are similarly equally qualified candidates, KubeFleet will shout them by their names and pick the top two solutions. In this case, KubeFleet will pick cluster A and B. The two clusters are all from the East US region. This is how KubeFleet scheduling process works right now. This works fine if this is exactly what users want. But in reality, we often have use cases where people want to say, "Hey, I want to run my workload in both the East US region and in the Central US region. I want to pick one cluster out of each region rather than pick pick one region altogether. This becomes a use case where the current API doesn't support very well. Now, to address this deficiency, we did add a feature called topology spread constraints. As you can see on the screen right now, this resource placement API now says something like, I want to use topology. Oh, hi, Luke. Yeah, so uh, for things and the proximity, kind of like that. The scenario we want to achieve here for this specific example would be like kind of like evenly spread workloads across clusters to achieve higher ability, that kind of use case. Yeah, I don't think people typically do achieve that by tanks, but proximity placement group is more closer. It's definitely more closer to the use case here. Yeah, so basically, the idea was to tune the distribution of resources in a specific manner, either to distribute it as evenly as possible, or try to make sure that everything stay in the same region as much as possible. Those are the different use cases that kind of related to the situation we have here. Yeah. So, like I mentioned, we added this feature called topology spread constraints, which basically allow you to say, hey, I want to spread workloads as evenly as possible across regions because I specify region as a topology key. And there's a max Q parameter, but basically saying that uh, I want to make sure that the region where with the most number of workloads is at most one more than the region with the least amount of workloads. So basically, make sure that the diff is no more than one. And with this new functionality for this specific use case is doable. But if you went one step more, when people want to say, "Hey, I want to spread my workload across three separate regions. I want to pick one from East US, I want to pick one from Central US, I want to pick one from West US." Suddenly, the topology spread constraints won't work anymore. Uh, uh, Say for the example we show on the screen right now, we have two clusters in the East US region, two clusters in the Central US region, and we don't have any cluster in the West US region. So it's when we give that to KubeFleet, given the resource placement API we have right now, KubeFleet will think that cluster A, B, and C are candidates for this one, and eventually will pick three out of the candidates A, B, and C. It won't recognize the fact that there's no cluster in the West US region. And you can see that the clusters from the East US region is overpicked, and the cluster in the Central US region is a kind of like a is underpicked, but it still doesn't violate the topology spread constraints because the skew between regions is still one. Basically, the West US region is ignored, the East US region is overpicked, and this whole semantics it doesn't meet what people really want in a typical multi-cluster scenario. I do want to mention that topology spread constraints is a feature that's already exists in a single cluster situation as a standard Kubernetes API. This situation is typically fine inside a single cluster because in a single cluster, Kubernetes kind of recognizes all the nodes as equal. But for clusters, things are different, right? A cluster from the East US region is not the same as one in the West US region. So the semantics we have with a typical Kubernetes topology spread constraints no longer apply in the use case we have on the screen there. So, and another complication is that our current placement API it doesn't track why a cluster is picked, and it doesn't really tell why which specific part of the selector cannot be fulfilled. So if you look at the situation we have right now, it's really difficult to say just by looking at the number of the final scheduling result why East US is overpicked and why West US isn't picked at all. There's also no way for people to actually see, hey, West US receives no cluster at all. I mean, technically speaking, you can still use some deduction to make this happen, but it will be a very cumbersome process. It will be very difficult to for our system to process. There are also situations where deducing the unfulfilled scheduling requirement based on the results is not at all possible. So this is a one major deficiency we face in our current placement API. And so that's why we have the enhancement proposal added right now is that we really wanted to make sure that KubeFleet will rise to a platforming oriented future where KubeFleet we want to make sure that KubeFleet can still operate in an environment where clusters can be provisioned on demand rather than just operating with a very fixed, very static set of clusters. And we also wanted to use this enhancement as an opportunity to address some of the usability complications we face in our current system. So what we show on the screen right now is a flow that's currently in the system about how to place the results across all the clusters. You first have to create a cluster results placement API object or a results placement object. Then you need to select some resources. We provide three separate modes. All those modes they basically concern how KubeFleet handles namespaces. And people have to choose one out of the three options. You can either place namespaces and everything within them. That's a default behavior. Or you can place the namespaces alone, or you can place one namespace and specific resources with them. But if you choose the third mode, one CRP can only select one namespace at a time. So those three modes of choices, they are very nuanced and they are very difficult for people to understand. And in some cases, it is still it doesn't really function very well. Uh, oh, Yeah, looking mentioned the computing resources still need to be provisioned, but I wouldn't say it's provisioned ahead of the time. It can also happen in the sense that when I have the specific requirements, I will go back in the slides a little bit more. Uh, sorry. So it can also work in this way. Let's say I don't currently have any clusters in my fleet, right? But I have the quota. I have the permission to access some computational resources. I have access to some GPUs, and I can mention to KubeFleet like I would like to run, I would like to have a cluster in that specific region, right? And with the help of the platforming code and cloud provider code, the cluster can actually be provisioned when I actually need them. Of course, the provisioning process itself will take some time. Yeah. Uh, but I do agree that for very expensive resources like GPUs, maybe especially about GPUs, people still tend to provision them, and I don't see many people create a GPU enhanced clusters on demand because it's a resource under some really heavy contention. But for more regular, for generic workloads, for applications, etc., it might be a different story because those resources are often readily available, right? And sometimes people even want to use the spot instances to benefit from the lower prices. So those situations also quite common in our world, I guess. So going back to our prior calls of discussion, I've just mentioned that for the resource selector part, you have three modes of choice. And we also offer three separate placement types. You have pick all, you have pick n, and you have pick fix. And people need to, a lot of KubeFleet users have reported to us that they find the three types a little bit difficult to comprehend, especially when we're just getting to know the KubeFleet and its capabilities. And after you pick a placement type, Oh, sorry, I think I missed a slide here. Uh, Yeah, so after you pick a placement type, you need to set up specific scheduling policies, and we have different features that's unique to each placement type. Say, for example, for pick all, you have access to cluster affinities, but because you are picking all applicable clusters, you are not allowed to short clusters by a specific cluster property. When you have pick n mode, you can use cluster affinities. You can short clusters by a specific cluster property, or you can use topology spread constraints. If you use peak fix, then all you can the only policy you can specify is just a list of cluster names. You can't specify affinities. You can't use topology spread constraints. So each placement type has its own specific set of policies that's only available to this type. And it takes some time to learn this association, which is which is another common feedback we hear from our customers. It takes some effort to get around with all those APIs constructs, API definitions in our code. And after you set up a scheduling policy, you need to pick a role type. We offer two. We have logging update and we have external, which is also called stage update at this moment. Logging update means that KubeFleet will automatically roll out changes to all the clusters in a progressive manner. Stage update means that people get to define individual stages. Like I can say cluster A and B belongs to the canary stage, B and C become the prod stage, and the KubeFleet will update the canary stage before it updates the prod stage. That's a general idea. And depending on the rollout type you choose, you might need to manually start a rollout to make the placement happen. So, for example, if you use a stage update, then your placement won't work out of the box. After you creating the placement, you need to start a rollout. Yeah, and eventually we get to check the people can start checking the placement status. This is another part where the experience can vary depending on the rollout tab you choose. If you use stage update, then the placement API won't be reporting aggregated status condition. So you can't tell whether a placement is available or not depending on the status condition. You need to check individual clusters directly. But if you use a rolling update, then we do have that status condition reported on the API. So there are many nuances about this. And as you can see, the whole flow it can be a little bit difficult for people to understand, for people to use. And we are really hoping that through this new enhancement, we can address some of the usability complications. So I would be just mentioning some of the key points about the proposal here, the enhancement here. So what we really want to do is that we wanted to add a new placement API called the placement policy in KubeFleet, and we want to really simplify the workflow so that the API only has two fields. You only need to specify some resource selectors and some cluster selectors to make it work. So for the resource selector part, instead of providing three separate modes, in this enhancement proposal, we propose that we take a more Kubernetes idiomatic kind of way. If you use a namespace placement policy, then you can only select the resources from the same namespace. But if you use a cluster placement policy, you can select any cluster scope resources or any namespace scope resources you'd like. This is the same pattern people have been using with say cluster row banding and row banding rows and cluster rows, etc. This is more of a Kubernetes standard. We'll be no longer providing separate modes in the resource selector. And another part about the cluster selector is that we redesigned this thing to make sure that each cluster selector represents individual scheduling requirement and constraints that KubeFleet will handle, KubeFleet will process. And with the new API, KubeFleet will start tracking all those selectors and their fulfillment. fulfillment status. Say on the screen here, you can see that the user is basically instructing KubeFleet to select two clusters from the East US region, select the specific cluster called Brave Lion, and select all the clusters under the environment under the Canary environment. And if, say, for example, there's no cluster in the East US region at all, then KubeFleet can request one. It's more like Kubernetes can provide a hint saying that, hey, a cluster is needed in that specific region. Yeah, sorry about that. Yeah, I typed that in kind of a haste. Really, really sorry about this. Yeah. So on the screen here, we are just showing match labels, but the label expressions and the cluster property expressions can still be used. So the semantics is still consistent between the current experience and this newly proposed experience. You can still select clusters based on cluster properties, based on labels, etc. Yeah. So, like I mentioned earlier, when a cluster selector cannot be fulfilled, Kubernetes can create a cluster request that basically notifies the current platform or cloud provider that a new cluster is needed, and it will be up to that platform or the cloud provider to provision new cluster as requested and join to the fleet on demand. So this will be an example of what a cluster request object looks like. So as you can see, it's a really simple object. It just features the scheduling requirement and constraints that need to be fulfilled, and it's up to the platform, up to the owner platform or the cloud provider to fulfill this request. Uh, the thing is, we designed this in a specific way to make sure that Kubernetes won't be the one that actually handling the provisioning. Cluster request, the presence of the cluster request API is more acting as a hint or a signal to whatever running behind the scene. It could be a specific provider, or it could be a cluster API implementation. It can be anything really. It's just providing a hint about the kind of clusters that Kubernetes needs right now. It's still up to the platform itself to prepare the cluster template to actually do all those provisioning to make things happen. What we do here is just adding a hint to the system. Yeah, and another yeah, I guess. Yeah, and we'll be also adding a annotation-based placement workflow. So the reason why we wanted to add this new thing is that we have observed that in many situations, Kubernetes users want to complete some very simple scenarios, like I just want to place a namespace to all my clusters, etc. In such simple scenarios, it wouldn't really be fair to asking people to write a full YAML object with the risk of having typos to fulfill this task. What we wanted to provide here is that we can allow users to simply annotate the resources, have them place. Kubernetes will create the corresponding placement policies automatically for such resources. So right now we are proposing three annotations, but there might be more scenarios we can add later. The three annotation will be placed to all clusters, placed to specific regions, or placed to specific clusters. The names here are just for demonstration purposes. It's not the set API, obviously, and still subject to change. And one really nice capability we can provide is that if this annotated result is a known Kubernetes API, say it's a Kubernetes deployment or Kubernetes daemon side, and it has some dependencies. For example, it's very common for a deployment to reference a config map or reference a secret. Then Kubernetes can help auto discover those dependencies and place those resources as well. So this is a new annotation-based placement workflow we will be adding. So this is pretty much the new system we are proposing right now. I do want to mention that as you can see on the screen, this is the architecture of the new experience. The general workflow is still consistent between what we have right now and what we are proposing. We are just making some slight changes to make sure that the individual scheduling requirements can be processed properly, to make sure that class requests can be added. We also made some usability changes. Uh, yeah, and so here's that. Now I do want to admit that a huge deviation, we are making a very huge decision here is in the sense that we are adding a totally separate placement API to KubeFleet. Basically, we are creating a dichotomy in the system. And I understand this dichotomy itself can itself be a source of confusion for many users because now people have two separate choices for doing the placement. And there are many scenarios, admittedly, that can be served by both APIs. But we feel that this is the right way to go, as I've just presented in the slides. Our current APIs have some limitations that really doesn't work well in the region we have for KubeFleet, and because we have existing users, we really don't want to take the risk of breaking any existing experience. Just technically speaking, it's still possible to tweak the current API. Basically, we can add aside from peak all, peak and peak fix, we can add a false placement mode with its own options. But doing so would further confuse users as our current APIs right now are already overburdened. And even with that, we still have to add a lot of exceptions and special cases to our code, which will make it less maintainable. And we also have to bear with the risk of breaking existing placement, which is something that we really wanted to do. So this is a very heavy decision that we don't really want to make, but it seems that that's the only option we have right now to make sure that we can still iterate on the new experience fast without breaking anything, and to prepare KubeFleet for vision, where clusters can be where we will be managing a dynamic set of clusters. So that's a general idea we are having right now. I won't go over some of the finer technical details in the document. I will revise this a little more as I know it's a very long one, but it would be really nice to discuss with anyone who's interested. And if you have any ideas or opinions or feedback, please feel free to let me know to add a comment on the enhancements. Yeah, we really wanted to learn how we can achieve this better, how we can whether the use case we are proposing right now still aligns with people's use cases or people's expectations of what a multi-cluster should be in the coming years. That's a general idea. Yeah.
Thanks, Chen. That was a stream of consciousness, if ever there was one.
Yeah.
A lot in there. It's a very deep enhancement proposal. I can see that we've got a few folks on the call, and we will post this video on our YouTube channel, and then probably post it to places like Slack and LinkedIn as well to get other people's feedback. But yeah, interested in first thoughts for this from folks who are maybe on the call. Feel free to come off mute if you've got questions or thoughts you want to share. We'd love to hear it. We've got some time left on the call, so yeah.
I mean, I'm wondering about the annotation based workflow, like how you, like you talked about that being useful for simple cases just to get started. So is that something that you think people would actually use in prod, or it's just kind of to lead people into the process?
Oh yeah, thanks, David. To me, it's more like uh, one obvious benefit would be to lower the barrier to entry. That's for sure. In a more production scenario, it can still be useful, I believe. There are cases where, say, for example, for the ops team, maybe all they want to place is just a namespace or just a specific policy. Then this annotation-based workflow will work just fine. We also there are also cases where say the results I want to place is not a typical Kubernetes results, but say like a cluster envelope we have right now, where it wraps around a group of resources. This is also a scenario where annotation-based workflow can help. Yeah.
Hmm. So do you think people will kind of graduate from that to the defining the full CRD?
Yeah. Let's see. I have a section here. Really sorry about this. I know there should be a the manual or some sort here. Uh, let's see. There should be one in the
I put you on the spot.
yeah. I know it's a really shallow example, but the idea was just you add an annotation, you annotate the results. KubeFleet will create the placement policy and do the auto placement. If you remove that annotation or if you delete the results, then the placement policy will be deleted as well. It's provided more or less a shortcut to create placement policies easier.
I think putting Fleet in the context of KubeFleet in the context of being a system for platform team to manage many clusters, um, which is then used by application teams, might make more sense here. As in the application team, you wouldn't want the application team necessarily to have to dive into all the details of KubeFleet APIs to be able to do the basics. What the platform team might definitely have that expertise, but lowering the mental model and barrier that we expose to the application teams means that the platform team adopting KubeFleet would not impact the entire organization to the point of everyone having to know the entire stack of KubeFleet to get started. Um, and I think that's quite powerful to be able to shield the app teams from the complexity of the platform infrastructure. Um, Now, if they have specific constraints and it becomes more complex constraints, then using the full API is still possible.
Right. So the team can prototype something, but then reach out to their cluster admins to do it in a more sophisticated way if things are working and they want to make it more official.
Yeah.
Oh, yeah, and look for the question you ask. Yeah, there's an interesting thing about annotation-based workflow. It's a workflow that we need to handle with a little bit more caution because say I have access to the deployment API, but I don't really have access to the placement policy API. Because I have access to the deployment, maybe I can add annotation and make the placement happen, even though I'm not even allowed to make that, make the actual placement. So we definitely need some policies. In this document, I'm proposing using a validating the mission policy, but technically speaking, any policy solution can work. Basically, we need to guard very carefully about who has access to use this annotation-based workflow. It's something that we need to handle with a little bit more caution. Yeah.
Great. Thank you.
Yeah, I think Luke's got some good questions around policy. I mean, there are Kubernetes native ways to achieve what you're looking to achieve, and that's how um, Kubernetes and services like AKS deliver integration with their first party policy engines like Azure Policy. But in the context of KubeFleet, any solution we would propose would be purely Kubernetes based, which I think is what Chen was just talking about, right? And there are risks with something like this design where you you basically give somebody a proxy way to achieve something that exceeds um, their permissions effectively because you're delegating the responsibility to the underlying platform simply by adding an annotation. So I think it's a fair question, but it's definitely something that would be top of mind as this goes through design and implementation because the last thing you want to do is to give people the ability to do things like suddenly create 50 clusters in a location where they actually don't have any permission to do that. So it's definitely a part of the broader design goals.
Yeah, multi-tenancy is something that is another topic that we've been thinking very carefully these days about how to make sure that in the typical pattern would be just giving a dev team some access to a specific namespace, right? So we need to handle this thing very carefully. The current KubeFleet default stance is that you give some people access to a namespace and it can only place resources within that namespace. But this situation might not be very flexible for some teams. So we are definitely thinking thinking about ways to enhance that. But this might not specifically be in the scope of this enhancement. But yeah, we are definitely hoping to explore more and more use cases in that specific domain. Yeah, and for the scheduling question, I wonder if Luke, you've been talking about this part. In the enhancement proposal, we mentioned something about scheduler as well. I do want to mention that the scheduler here is not a Kuber scheduler replacement. It's just a KubeFleet specific thing where we match scheduling constraints, scheduling requirement with specific clusters. It's not like a Kuber scheduler that's actually binding pods to specific nodes. Yeah.
But it's more of like you could go, I don't know, I'm just making shit up. Like Friday, I don't know, like these workloads need to exist in these regions. I don't know, during this period of time, essentially, and then like, is that the schedule that you're talking about, or is it?
Yeah. So basically, it's just picking clusters based on specific scheduling requirements. We don't have any time-based placement support at this moment.
Yeah.
But this is a very interesting use case. Something more like a cron job, I guess.
Yeah. So yeah, that's probably that's what I was thinking when I saw it. But
Yeah, it's a generic, I think in the context here, it's a generic scheduling framework. So it is probably more akin to the scheduler in terms of what it's trying to achieve, being more like the Kubernetes scheduling capabilities, but it's not a replacement for individual cluster scheduling from a Kubernetes control plane standpoint. But obviously, we need a multi-cluster version of that in some capacity. In fact, we already have that as part of KubeFleet today. So yeah, I think it's less about time and cron based scheduling and more just about general scheduling of not just workloads, but basically taking those policies and making sure that whatever is required to meet the spec is handled effectively by KubeFleet.
I think, correct me if I'm wrong, Chen, but one of the reasons for moving to policy-based API, policy type of API, is that as the set of clusters becomes more dynamic, we want to be able to reevaluate the scheduling of the workloads on the clusters. And right now, what we record is like the declarative way to define where the workload lands is that contains the set of clusters, and so it's not clear how to express that reevaluation and separate it from the placement.
Yeah, that's definitely true. So we do want something to be like in a more dynamic environment. The evaluation policy and the re-evaluation policy, all of those can offer tremendous values. We do have cases where people want to say, for example, when one specific region run out of capacity, there with a right side of policy, it might be able to do some rescheduling based on that, some rebalancing based on that. So yeah, it's definitely true that we wanted to lean more in that direction.
Any other questions from folks? No, I think we're pretty good for today's session. Chen, do you have like just the detailed slide again if people want to get in contact and things like that? You can put up back on the screen.
Yeah. So let me just use this one. Yeah. So if anyone has any concerns about this, please let us know. We have the link to the enhancement proposal is here. So if there's any comments, feedbacks, please let us know. I know documentation is a little bit long at this moment. We'll revise this to make sure that it's easier to read and to make it more focused. Yeah.
We're interested in feedback and thoughts, and if people want to contribute, we definitely want to hear from you as well. If you think there's things that we're missing, we'd love to hear that as well. We see a lot of value in shifting to a more dynamic approach to doing placement. But as Chen said throughout today's sessions, that's not in as a replacement for what KubeFleet already offers today, which works really well. And as we've seen in earlier sessions with Chen talking about scalability, has been thoroughly tested and, for that sort of scale. So this is really about that next level experience on top of the foundation that's already been built for KubeFleet. So please reach out. We'd love to hear from you. Cool. Any last words, Chen, before we wrap up today?
Yeah, just thanks everyone, and it's a new direction we are taking. We are excited, but also a little bit concerned about this about the future we want to go. But this is a vision that's very interesting, and we really wanted to bring KubeFleet to the next level, to prepare for the coming future. That is, so yeah, really looking forward to hear about feedbacks and possible use cases. And thanks so much for all the questions today. Yeah.
All right, everyone, we will see you in our August community meetup. Thanks a lot for your time today, and we look forward to hearing from you really soon. Bye for now.
Thanks. Bye.